Hello, this is Miss Cheney, Algebra 1 teacher at Hart County High School. Today's lesson is going to be on compound inequalities. Compound inequalities can be written as an and problem, or sometimes we call them or problems. An and problem can be written in two ways. It can be written like this, using the word and in between, or it could be written like this. This is another way to write an and problem. An or problem can only be written one way. And that would be how you would write an or problem. Now, when you're solving compound inequalities, you need to remember that you're going to solve them exactly the way you would solve an equation. We're still going to use inverse operations. The one that's the most different is this and problem. And we're going to look at how to solve this and problem in just a moment. So let's start with one of those. Let's start with one of the and problems that is combined into one. So here's the first example we're going to look at today. Now, when you're solving any inequality or any equation, you always want to look and find your variable first. So here's my variable x, and if you notice, it is between the two inequality signs. And in here with the variable x, I have a plus 4. So I know, just like when I learned how to solve equations, that in order to solve any equation or inequality, my goal is to get the variable by itself, to isolate the variable. So I'm going to ask myself, what is inside, in between these two inequality signs, with my x that I need to get rid of? Well, I have a plus 4 here, and I need to get rid of that plus 4. I need the x to be by itself. So what can I do to plus 4 to cancel it out? Well, I'm going to do the inverse operation, which is to subtract 4. And then I have to subtract 4 from all three parts of this compound inequality. The 4's in the middle become 0. That leaves me with only an x. I'm going to bring down my inequality signs. 10 minus 4 is 6. And 6 minus 4 is 2. Now my x is isolated, and this is my solution. Now, just like with any inequality, we are going to graph this compound inequality. And I'm going to put a 0 down here just as a reference point. This inequality says 2 less than x less than 6. So I'm going to cover up this half of my inequality, and I'm going to say, well, what does this say? This says x is less than 6. Less than tells me I'm going to have an open circle, and less than also tells me that my graph is going to be shaded to the left of that number. Now I'm going to cover up the other half of the inequality. This says 2 is less than x, or I could read it, x is greater than 2. Again, this tells me I'm going to have an open circle, and greater than goes to the right. So that's what my graph for this and compound inequality would look like. Another and problem would look like this. Let's do Okay, here's another and problem, and it's a compound. And I would like for you to pause the video and work this problem out, and then play it again and see if your steps are the same as my steps as I work it out. So go ahead and pause the video, work it out and graph it, and then play it, and you can see how I work it out and graph it as well. Okay, my first step is going to be add 3. My 3's become my 0. Here's my x in the middle, and now it is isolated. 15 plus 3 is 18. Bring my sign down. -4 plus 3 is -1. Now let's graph. -1. Here's 18, and here's my 0 just as a reference number. I'm going to cover up this part of my answer. X is less than 18. Less than is going to be an open circle. Less than goes left. I'm going to cover up this part, and this now says -1 is less than x, or it could say x is greater than -1 if you want to read it backwards. Greater than tells me I have an open circle, and I'm going to shade to the right. So that's what my graph for this and compound inequality would look like. Okay, next we're going to look at an OR problem. We're going to look at an OR inequality. Remember, an OR inequality is written with the word OR in between your two inequalities. So it's written actually with the word OR. So all I'm going to do is I'm going to solve each of these inequalities individually. So I'll start here. Once again, here's my variable x. I want my x to be all by itself. So that means I have to get rid of or cancel out the number that's with that x by doing its inverse operation. The inverse of adding 7 is subtract 7. My 7's become my 0. That leaves me with x by itself. Bring down my less than sign. Let's put an equal to with this one. Okay, let's put an equal to with this one. 11 minus 7 is 4. Okay, so there's my first half of my answer. I don't have my full answer until I get this side as well. Again, here's my variable x. What am I going to have to do to minus 5? To get it to the other side, I have to do the inverse, which is add 5, and then add 5. My 5's become my 0. X is greater than 6 plus 5 is 11. And here are my two answers. Remember, again, this is an OR problem. When I graph this inequality, I have a 4 and an 11. This inequality says x is greater than 11. Greater than tells me I'm going to have an open circle. Greater than goes to the right because the numbers that are greater than 11 are numbers that are to the right of 11 on the number line. This answer says x is less than or equal to 4. Because it has the or equal to, remember that that means we have a colored in circle. Less than goes to the left because numbers that are less than 4 are to the left of 4 on a number line. Okay, now here's your next problem I want you to do. Okay, copy these problems down, this inequality down. Press pause on the video, work it out, and then when you finish, play, and you can see if you get the same answer as I do. Okay, my first step is to add 3. X is less than 11. My first step here is to add 5. X x is greater than or equal to 17. Again, this is an OR problem. So when I graph, I have an 11, I have a 17. X is less than 11. That less than tells me it's an open circle, and my graph goes to the left. X greater than or equal to 17. Greater than or equal to tells me it's a colored in circle, and my graph goes to the right. Check your graph. Make sure your circles are the same as mine, open circle, closed circle. Also check your inequalities and your signs as well. There is more to solving inequalities that we will go over in our next video.